Hello everyone. So here we are back again with the next chapter, that is Triangles 1 chapter 8. So in this we're going to learn about some theorems. Maybe we might recall a few theorems as well. So the first part of it, the first theorem that we are going to go ahead with is the exterior angle formed when a side of a triangle is produced is equal to the sum of the two interior opposite angles. Now let's first understand what does that actually mean. So if you look at this part, they're saying the exterior angle formed. So in this triangle, ACD is the exterior angle. The exterior angle formed is equal to the sum. When they say sum means the total of two interior opposite angles. Now we know that there are three interior angles, right? But which two are we going to choose is the question. They're telling us interior opposite angles. Now if you take this one, this is the interior adjacent angle. That is the angle with the exterior angle. So we call it adjacent. But they're talking about the interior opposite angles. Therefore we know that we need to add angle A plus angle B. So angle A plus angle B, which would give us the angle ACD, the exterior angle there. So that's exactly what the theorem means. Let's look into the questions to see what more we have there. So in example 1, we have find the magnitude of ACB based on the information in the figure. Now we have the triangle, the exterior angle is 110, and like I told you, this will not be here. This is the adjacent angle. So we know that this is the angle ACB plus 60 degrees is equal to 110. So ACB plus 60 equals 110. So let me just quickly write that down. Plus 60 equals 110. So now to find ACB, what do we have to do? We have to do the inverse. So from 110, we need to subtract a 60 there. So when we do that, we get the angle ACB, which is equal to 50 degrees there. So this angle would be 50 degrees. Now likewise, let's look into the next question itself. So in example 2, what do we have? Based on the information in the figure, find the magnitudes of angle AEB and BCE. Now AEB, let's first mark which angle they're referring to. Okay, they've already given it as AEB as X and BCE as Y. So another important thing, where this angle mark, this crowbar like thing comes, that is exactly where the angle that they're referring to is. So now how do we find X and Y is the question that we have. So we need to choose the right triangles. Now there's only one theorem that we have done so far. So we know that this is 70 and 25. If you look at this, we have a triangle that is forming right here, the triangle AED. And this is the exterior angle for that. So X is equal to basically 70 plus 25. So we can write that as X equals 70 plus 25. So 70 plus 25, X is equal to 95 degrees there. So that's pretty clear over there. And now we need to find Y. So for that we need to choose the right triangles once again. So let's see which triangle is the ideal one to get the answer for Y. Now if you look at this one, you see that we have this triangle BEC. Now BEC, the angle X is the exterior once again. But this time it's 40 plus Y equals X. Now 40 plus Y equals X. But we've already found X to be 95. So I'm going to replace that X with 95. Now we need to find Y. So to find Y, we need to do the inverse. So from 95, we subtract 40, which would give us the answer 55. So Y is equal to 55 degrees. Let's not forget the degrees over here. We need to definitely make sure that we put the degrees to get the correct answer there. So that's how we work out finding angles using this theorem. Now let's see what we have in the next lesson. The exercise itself is pretty easy, where you have to use the theorem and find the unknown angles here. So with that, I'll just move to the next part itself, where they're talking about the formal proof and applications of the theorem on the exterior angle of a triangle. Now the formal proof is something which used to come in the past papers, but after some time it was stopped, and then once again we saw a trend where the formal proof is asked. So let's make sure that we try to have an idea at least how exactly, what is the formal proof of the theorem that we just spoke about. So we said that the exterior angle is equal to the sum of the interior opposite angles. Now to prove that, we're going to use this triangle ABC, and we've extended the line BC to D. So the data, the side BC of the triangle ABC has been produced up to D. That's what we've done. We've extended the line. What do we want to prove there? That angle ACD, that is the exterior angle, is equal to angle ABC, that is this angle, plus angle BAC, the interior opposite angles, the two interior opposite angles. So now how do we prove it? For that we need to do a slight construction there. The construction is we are going to draw CE. We are going to draw a parallel line from C, which is going to be parallel to AB. A line parallel to AB from the point C. Alright, now let's see what we can do over here. So if you look at this triangle really carefully, you will see, like, there is, now we have parallel lines, we have an alternate angle forming. So when it comes to parallel lines, we speak about three angles. One is the alternate angle, that is where it forms an Z shape. And then we talk about the corresponding angle, which is more like an F shape. And then we have the allied angle, which is like, you can say it's like a C or a U, but like in a square form. Not exactly this way, but it will be when if I have to really draw it out, it will be something like this. So, alright. Now, in allied angle, there's a slight difference. In alternate angles, we say that these two angles are equal. This is equal to this. And corresponding also goes with the equal part. I will show you with the example here. But when it comes to allied, we tell that the angles, these two angles here, they add up to 180. This is about the parallel line theorems. We will maybe look into that in detail on a later day. But today, if we are referring to this exactly, this question here, we need to find the formal proof. So we know that this is an Z forming, an alternate angle. So we can say that BAC is equal to angle ACE. So BAC is equal to angle ACE. So let me just write that down. And here we go. And the reason, if you're referring to the reason, you can say the reason would be alternate angles. So I'm just going to write it as alternate there. Now we've proved one part, but we need to prove another part. We have this part here. We have to prove that this is equal to this. So here comes the corresponding angle itself. So if I'm taking this a different color to show you the F that I referred to. So this is the F, right? The F that is like, a slight turn over there. But this F, when we say equal, this angle, the angle below the arms are equal. So if this angle is ABC and below this arm, the angle is ECD. So based on this, we can say that ABC is equal to angle DCE or ECD. Either way, it will be correct, ECD. So there we go. We've proved the next part. So now let me just put a few numbers there. So if this was X, we say that this is also X. And moving to the next part, if this is Y, we say that this is Y as well. So if you look carefully, the angle ACD, which is the exterior angle, is basically X plus Y. ACD is equal to X plus Y. So likewise, if you refer to these angles that we have, ABC and BAC, they are also equal to X and Y. So ABC plus BAC, I can replace ABC with an X here and BAC with the Y. So if you look at it, we have ACD, which is equal to X plus Y. So here we go, we've proved our theorem that ACD is equal to ABC plus BAC. So that's how we show the formal proof of this theorem itself. So moving on to a few more questions. When look at this example one, they've spoken about the point S is located on the side QR of the triangle PQR. So we have the triangle PQR and the point S is located on the side QR. So sometimes they give you just the statements and you've got to draw the diagram. So this is something like that where we have to draw the diagram. So we need to figure out, okay, what are we going to do first? We need to draw the triangle PQR. So that's exactly what they've done. They've drawn the triangle PQR. And then they've located S on QR such that PQS is equal to SPR. So PQS is this angle is equal to SPR. So we need to, now if I, for example, put S over here, that may not be correct because in that case, the SPR angle is extremely small. So we need to figure out exactly where do we have to put the S by looking at this angle given here. And now we need to prove that QPR, which is this angle here, is equal to PSR. We need to prove that these two are equal. So now how do we prove using the theorem that we just learned? That the exterior angle is equal to the sum of the interior opposite angles. So if you look at the triangle PSR, or the angle PSR, is the exterior angle of PQS triangle. So let's just quickly draw the triangle. Now this is the triangle PQS, and we have PSR, which is the exterior angle. So if I have to write PSR is equal to the sum of the interior opposite angles, which means it is equal to PQS and QPS. PQS plus QPS. That is, if I'm referring the exact angle, if I'm referring to, that is this angle, PQS plus QPS. These two angles, they add up to give the answer PSR. So now we've figured that out. What will our next step be? Now we need to prove that this angle here, the PSR, is equal to QPR, that is this entire thing here. Okay, so we have to prove that this PSR is equal to this entire thing. So what is our next step there itself? Now QPS plus PQS is there, but we know that PQS is equal to SPR or PSR. Sorry, SPR, not PSR, as SPR, or we can say RPS. That is, we are going to replace PQS with the data that they have given. Now, what was the data that they gave? That PQS is equal to SPR. That is this part here. So, I'm going to replace PQS with SPR. So, PSR is equal to SPR plus QPS. And the reason is because they've already told us that PQS is equal to SPR. That's the reason that we are replacing it. So now let's say we have PSR equals SPR plus QPS. Okay, let's look at these two angles. SPR plus QPS. So basically when you add these two, you're referring to one big angle, that is QPR. So these two put together would be QPR there. So I can replace, I can tell that PSR is equal to QPR. So if you look at the question, that's exactly what they want us to prove, that QPR is equal to PSR. So with 3 steps, we are already done with it, and we can say that they are equal based on axioms as well, because QPR is equal to PSR, and they've given us the reason being axioms. So in grade 9, you must have learned what is axioms. A equals B, B equals C, therefore A is equal to C. That is one type of axioms. You must have learned a few more types as well. So moving to the next examples itself. So if you look at this example 2, based on the information in the figure, prove that angle BAC. So once again, let's see which is BAC, that is this angle, plus angle ABC, plus this angle is equal to angle DEC, this angle, right? So we need to prove that the total of these two angles marked in green is equal to the angle marked in red. All right, let's look at it once again. So if I'm looking at this triangle ADE, so ADE, they have extended this line. So DEC is the exterior angle of this triangle ADE. So based on the theorem, DEC is equal to the sum of the interior opposite angles. Now the interior opposite angles would be this A and this D. So how do I write them down? I can write them down as, here it's going to be, we can say BAC or DAE. Either way it's not wrong, but we can, since we are talking about the angle BAC, I'm going to take it as BAC. So BAC plus angle ADE. These two are the interior opposite angles. Now if you look at this one, I have, which means now partially I have already found half of my equation. I have DEC, which I want, and I have BAC. So now I know that I have to somehow replace ADE with ABC. So I've got to figure out how am I going to do it. So if you look at ABC and ADE, you will once again see the corresponding angle, the F being formed there again. So if I'm going to change the color there, so if you'll see this, here we go. So you will see that the F that is formed here, now this time it's like an upside down F, but this F is the corresponding angle. So ADE is equal to ABC. So there we go, we can replace that ADE with ABC. So when I do that, I have the equation DEC equals BAC plus, instead of ADE, I'm going to write ABC. So before this line itself, you can show that ADE equals ABC and put the reason as corresponding angles. So that's exactly why your so corresponding angles there. So that's exactly why we are using axioms here. So ADE is equal to ABC. So we replace that ADE with ABC because they are already equal and we prove them under corresponding angles. So the only thing that you have to be mindful in this case is know the theorems really well and understand parallel lines, because we have a lot of parallel line questions coming in, alternate, corresponding and allied. And then we have to also read the question carefully, understand what the diagram says, and try to put in your theorem knowledge, or the knowledge of theorems that you have into the questions itself, and then I think that would be really easy for you there. So with that, we have completed the first theorem itself in this question, and we have the exercises there. So you can go through that. There are some word problems where you will have to draw the diagram. So you have to understand what they're trying to say clearly, and then draw the diagram, and then complete the questions as what they say. So moving to the next theorem itself, this is a theorem that you must have definitely learned in your smaller class as well. The sum of the interior angles of a triangle is 180. So again, the sum of the interior angles, which means the total of the three angles, is equal to 180 degrees. So if you look at this example, 60 plus 40 plus this angle C should give you 180. So 60 plus 40 is 100. So 180 minus 100 would give you 80 degrees. Now in this one, if you have to write it down, you can say that 2x plus x plus 30 is equal to 180. So 2x plus x is equal to 3x plus 30 equals 180. So once again, I need to subject x. I need to find x there. So for that, I'll leave 3x as it is and take 30 to the other side and do this subtraction, do the inverse. 180 minus 30 is 150. So 3x equals 150. Now to find x, I need to divide both sides by 3. So basically x is equal to 150 divided by 3, x is equal to 50 degrees. But remember, that's not exactly the question itself here. In this part, they're asking us the value of x. But if they tell you find the interior angles, then you can't leave the answer as x itself, because you need to find what 2x is also. So 2x would be x times 50, which will be 100. So if you want to check if your answer is correct, you can do this: 100 plus a 50 plus 30. This should give you a total of 180. So 100 plus 50 is 150, 150 plus 30 is 180. So we know that we found our answer correctly. And moving to another example there. The straight lines AB and CD intersect at E. So AB and CD, they intersect at E. If ADE is 35, ADE is 35, DAE is 70 and ECB is 55, find the magnitude of CBE. They want us to find the magnitude of CBE. This is the angle that they're referring to. So now we need to figure out, okay, well, how am I going to find this part itself? So we know that 70 plus 35 over here, we can find out this angle and then use vertically opposite angles and then add the totals itself to get 118 from this triangle. That's one method that we can apply. Or we can also apply the exterior angle theorem. 70 plus 35 would give you this angle, which is 105. So 55 plus b also should give you the same. Even that way you can figure this answer out. So both the methods are correct. It's up to you which method you choose. But since we're doing about some of the interior angles, we'll go with that method for now. So 70 plus 35 plus the angle AED is equal to 180. So to find AED, we need to subtract 70 plus 35, which is subtracting 105. So 180 minus 105 there. So which is equal to AED is equal to 75. So if AED is 75, once again looking into this question, 75 plus 55, because we're using the vertically opposite angles, that is if this is 75, we know that this would also be 75. So 75 plus 55 plus the unknown value, which is CBE, should be equal to 180. So once again 75 plus 55 is something that we need to add there. So when you add 75 plus 55, you get 75 plus 5, 80, 80 plus 50 is there, 130. So CBE is equal to 180 minus 130. So CBE is equal to 50 degrees in that case. So here we go. That's how you figure it out. CBE is equal to 50 degrees. So based on that, we have exercise 8.3 where they've given the same questions where you have to find the angles. This one, a plus 10 and a minus 3. It's the same thing like how we did the x question there in the previous example. Once again, we're coming to the formal proof of this theorem as well. Now the theorem here is the sum of the interior angles of a triangle add up to 180 degrees. So what is the formal proof and the application over here? So it's the same thing. ABC is a triangle. This time they've extended BC to D again, and they have also drawn the parallel line parallel to AB from C. Now we need to prove that these three angles add up to 180. So okay, we used the previous theorem and we figured that angle A, BAC, is equal to angle CAE. We already know that because it's the alternate angle. Likewise, if I have to change colors, then ABC is equal to ECD. Even that was proved, corresponding angle. So angle C is common, and if you look at this one, this is a straight line. So the blue plus the red plus this angle C, or the ACB, should be equal to 180 because it's a straight line. So if I have to label them, if I say that this is X and this is Y, and this is Z. So at the same time we have X, Y and Z here as well. This is X and this is Y. So X plus Y plus Z is equal to 180 because it's angles on a straight line. So same X, Y, Z is applied here as well. So we can say that these three angles add up to 180 degrees. So that's exactly what they've shown using the letters, or not X, Y and Z actually, but A, B, C, B, C, A. They've labeled the angles there and shown us that. So moving to the example itself, prove that ABD is equal to BCD based on the information in the figure. ABD equals BCD. So ABD is this angle and BCD is this particular angle. So we need to prove that these two angles are equal. All right, let's see how we're going to prove it. So first thing that we're going to do is we're going to see in triangle BDC. Okay, so BDC, we know that this is X, this is 90. It's a right angle there. And this is going to be 90 minus, if you take this as X, then this is going to be 90 minus X. Or if you want, you can label this as X over here. So we're just labeling that as X. So now if you look at this carefully, you know that X plus 90 plus this angle BCD should be equal to 180 degrees. So basically, if this is 90, these two angles should add up to 90 degrees. So if I'm going to write it down, it will be X plus angle BCD should be equal to 90 degrees, because out of 180, a 90 is gone, so the next 90 remains. So BCD can be written as 90 minus X. Now 90 minus X, we're done. And if you look at this part here, angle ABD also can be written as 90 minus X, because this is a right angle triangle. ABC is a right angle triangle. So from 90, you're subtracting this, what you wrote as X. When you subtract that, you're getting the answer ABD. So ABD also is written as 90 minus X. So if both of them are equal to, BCD is equal to 90 minus X, ABD is equal to 90 minus X, basically BCD is equal to ABD. So there we go, we've proved what they've asked us to prove. Now this is like the short form to explain it to you, but when we are writing the answers, we can't write like that, so we have to show exactly what we're trying to say. So this is how they're going to write that BDC is equal to 90 degrees, and BDC plus DBC plus BCD, that is these three angles, they add up to 180 degrees. So DBC plus BCD is equal to 180 minus 90, that is equal to 90 degrees. So they've shown this, what we already showed, that these two add up to 90 degrees, that they've put it as line 1 or the equation 1. And moving to the next part, what they've done is they've done in the triangle ABC, in the bigger triangle, ABC is 90. So these two angles, they add up to ABC is equal to ABD plus DBC. ABD plus DBC, these two angles that they have given here. And then they're showing us that the ABD plus DBC is equal to 90 degrees, because we already told ABC is 90. We're replacing that with 90 here. So now that is equation 2. So if you look at that, both of them are equal to 90. So ABD plus DBC is equal to DBC plus BCD. Now DBC and DBC are both common, so we just cancel them off or subtract them off. So then we are left with BCD equals ABD. This is the worded format of showing how they are equal, and this was how I explained to show you that using short methods, using x and y. You can use x and y if you find this difficult, but you have to tell that this is what you're referring to as x. So if I refer to DBC as x, I have to initially mention DBC is equal to x, and then I can continue using x or y, any unknown term. There's no problem with that. So those are the examples that we had under that. And exercise 8.4, you have a few questions how to prove that using this theorem. So these are two theorems that we have learned. Now this is just the beginning of geometry coming in. We will be learning more theorems in the upcoming lessons itself. So altogether we will have a lot of theorems, and in your final paper you will have a mixture of all. So you have to really understand and look at the diagram and figure out which theorem you're going to use in which case. So that will definitely come up with practice itself. So with that, we're done with today's lesson. So thank you very much for joining in, and have a nice day. Don't forget to like, follow and subscribe. Thank you. Have a nice day.